In today's class, we will solve a few problem sums based on number systems which are of level 2. The first problem sum says that which of the following fractions lies between 2/3 and 5/7. The numbers that are given, their denominators are different, 3 and 7 respectively. And when we will solve this type of problem sum, what we will do is we will make the denominator same, so that with respect to that denominator we can compare the numerators. So here what we have to do is we have to take the LCM of both the denominators. So here 3 and 7 both are prime numbers, so there will be no common divisor or factor. So their LCM will be 21. Now what we will do, we will represent both the numerators with respect to this new denominator. The second number is greater than the first number as their denominators are now same, so we can easily comment on that. And now we have to fit all these four options with respect to this new denominator, which is 21. Now the first number 3/4, when we will work on that, we can see here the denominator is 4 and here the new denominator is 21. Again the denominators are not same, so what we have to do is we have to make both the denominators same. Again the same concept, LCM. Between 4 and 21, when we will take the LCM, the new value of the denominator will be 84. So 84, and 84 divided by 4, it is 21. So the new numerator value will be 3 multiplied by 21. As when we multiplied 21 with 4, we got 84. So the new value with respect to the same denominator will be 63 divided by 84 now for this value. And now for these two numbers also, if we evaluate separately, then 84 divided by 21, it will be 4. That means numerator will be also multiplied by 4. So 14 multiplied by 4, and here it is 21 multiplied by 4. So this number will be 56 divided by 84. And the second number again 15 multiplied by 4 and 21 multiplied by 4, that will give us the denominator will be 84 and numerator will be 60. So now between the first number, second number and the first option, now the denominators are same, and that is 84. So now we can easily compare their numerator value. So what we can easily see here is 63 is more than 60, so it doesn't lie between 56 and 60, so option A is not correct for us. And same approach we will be applying for other three options. So 4/5, again 5 here is the denominator and 21 is the common denominator between both the given numbers. So again we will take the LCM. 5 multiplied by 21, as they don't have any common factor. So here the LCM will be 105. It will be 84 and here it will be 105. So now what we can see here, their denominators are same. So 84 again is more than 75, so 84 doesn't lie between 70 and 75, so this option is also not true like the first option. Now 5/6, 5/6, third option, 6, between 6 and 21, if we take LCM, they have common factor, so it is 3, this is 2, this is 7. So their LCM value will be 42. Now 42 divided by 6, it will be 7. 7 multiplied by 5, it will be 35. So 35 divided by 42. And this number if we represent, then 42 divided by 21 is 2. 14 2s are 28. So 28 divided by 42, and the second number again 15 will be multiplied by 2. So 30 divided by 42. Again 35 is more than 30, so this option is also not true. Now the fourth option, 4/7. So between 7 and 21, if we take the LCM, 7 is the common divisor, or we can say 21 is the multiple of 7. So their LCM value will be 21 only. Now if we evaluate, then we can see 12 is less than 14 this time. So again it doesn't lie between 14 and 15 or both the given numbers. So this option is also not true. And the fifth option, what we can see here, none of the above. That means this is our correct option. Now the second question, it says that which of the following is true. Option B has to be the correct option, as we know that square root of A multiplied by square root of B, that has to be equal to square root of a multiplied by b, and that multiplication will be done within that square root, and that is one of the properties of square root that we know. So option B is always true. But what about the other options? Other options we will prove here by taking a set of values. Say if we take a is equal to 16 and b is equal to 9, we can take any values as a and b, this 16 and 9, they are perfect square. So it will be convenient for us to check this relationship. That's why I have chosen these values. And between 16 and the 9, they also follow the Pythagoras theorem. So option A is root over a means root over 16, so it will be 4, and root over b means root over 9, it will be 3, so it is 7 left hand side, and right hand side is root over a plus b. So root over a plus b means 16 plus 9 25, and root over 25 means it is 5. So what we can see is 7 and 5, both the values are different, so option A is not true. This we have already seen. Now the third option, so root over a means 4 and root over b means 3, so it will be 1, and from the right hand side it is root over a minus b, so 16 minus 9, so it will be root over 7. Root over 7, we know it will lie between 2 and 3, because 4, square root of 4 is 2 and square root of 9 is 3. So this value will lie between 2 and 3. Anyway, whatever will be that value, that will be more than 1. So this relationship will also not be true for us. Then the fourth one, root over a plus root over b. Root over a means 4, root over b means 3, so it is 7. And from the other side, what we can see is root over a means 4 minus root over b, and that is 1. So this left hand side is more than or greater than right hand side. In the option it is given less than, so this is also not true. And at the same time, what conclusion we can draw is root over a plus root over b will never be equal to root over a plus b, but will be always greater than this. So this we have to remember. Second option is always true, and the third option what we have seen is root over a minus root over b is less than root over a minus b, so that is also true always, and that we have to remember. And the fourth option, root over a plus root over b will be always greater than root over a minus root over b. So this is another set of conclusions that we can draw, or this is another set of relationship that we should remember to save time in exam. Now the third question says, now we know the definition of rational numbers. Now if we individually assess x, y and z, root 3 we will see that this is an irrational number, because this is a non-recurring and non-terminating decimal. So this will be an irrational number. Similarly, root over 27 also we will see that non-recurring and non-terminating decimal, so that will be also a irrational number. But if we multiply these two, x and y, as we have seen just in the last example, that it will be root over 3 multiplied by 27. Now if we factorize 27, it will be 3 multiplied by 9, and 9 also 3 multiplied by 3. So inside or within this square root, what we can see here is we have even number of 3. So when it will come out of the square root, it will be 3 multiplied by 3. Right? So as within the square root we have 4, so outside the square root we will have 2. So it will be 9, and 9 is a rational number. So this option is true. Then the second option, xz. So if we factorize further 3 number of 3's, so finally this number or this value will be 9 and then 27, which is a rational number. And what about the third option? Third option is yz. So finally it will be 27 multiplied by 3, it will be 81, which is also a rational number. So our correct option will be all of the above or all of these. Now the fourth question, 0.3 bar plus 0.45 bar, both the recurring numbers, when we will be adding, what result or value we will be getting. So 0.3 bar means this 3 after decimal point will be repeating. So it will be 0.333, and so on. And 0.45, this is also a repeating or recurring decimal, so it will be 0.4545, then again one set of 45, and so on. Now when we will add these two recurring decimal, so how we will represent this recurring decimal? It will be 0.78 and then bar, and that's what we have in option D, 0.78 bar. So that will be our correct option. Now let's move on to the next question. X is the smallest 4-digit number formed by all the digits 0, 7, 8, 9, and Y is the greatest 4-digit number formed by, again, by the same digits 0, 7, 8, 9. So what will be Y minus X? Now 0, 7, 8, 9, in ascending order, first we have to arrange all these digits. So 0, 7, 8, 9. So this will be the smallest number. But at the same time, this has to be a 4-digit number. But if we place 0 at leftmost position, then it will be no more a 4-digit number, rather it will be a 3-digit number. So what we have to do is we have to swap the positions of 0 and 7. So it will be 7 and 0. We cannot interchange the position of 0 with 8 and 9 because that will not keep the number smallest. And if we want to form the greatest number by taking the same digits, then we have to arrange the digits in descending order. And then if we want to subtract smallest from greatest, then the result of subtraction will be 2781, and that we have in option 2. Now the next question says, and this is also a recurring decimal. Again, this is also recurring. So what will be the result of this subtraction? So it will be 7, it will be 1, then again 7, then 1, and here again it will be 7 and 1. Then it will be 17.17 and then bar. With respect to this bar, if we represent, this will be the number. And if we want to represent this as a rational number, then we know what will be the approach. So it will be the whole number without the decimal point and without repeating the digits, and in sequence we write all the digits, and then we subtract the whole number that we obtain by taking only the non-recurring digits, and that is also 17 here. Before decimal point we have non-recurring digits, then we have 10 to the power p, or the power is the total number of digits that we have after decimal point. So here we have 2, so it will be 2 minus 10 to the power, here power will be the total number of non-recurring digits after decimal point, which is 0. So the final value 1700 divided by 99, which is a rational number. So both the ways we can represent. If we don't have any set of given options from where we want to choose or we have to choose, then the next question is, what is the least positive integer that should be multiplied to 720 so that the product obtained is a perfect square? So this is a question of perfect square. That means 720 is not a perfect square. What we feel from by going through the question, 720 is not a perfect square. We have to multiply some other value or some other factor so that the number after multiplication will be a perfect square. So in this type of question, what we have to do, we have to first check what are the factors that the given number has. So if we factorize, then it will be, so what are the factors 720 has? So 2 and 2, they are in pair. 3 is also in pair with another 3. 5 has only one occurrence in 720. That means the shortage is this factor 5. So if we multiply another 5 with this, then that will make the number after multiplication a perfect square. Then the square root will be. Now the next question and the last question of this class, we have to arrange the following fractions in descending order. Now the 4 fraction values that are given, if we look at them, then what we can see is their denominator values are different. And again, this is same as the first question that we have solved. So what we have to do is, here we have to take their denominator values 12, 15, 25 and 45, make their denominator values same, so that with respect to same denominator value we can compare their numerator values. So what we have to do? We have to take their LCM. The LCM here will be 900. Now we have to represent all the numbers with respect to 900 as denominator. So 900 divided by 12. 12 means 3 and 4, right? So what are the remaining factors? 5 and 5. 5 5s are 25 and then multiplied by 3, 75. So 75 when it is multiplied by 12, that gives us 900. So numerator at the same time will be multiplied by 75. And what will be the new value of that fraction? It will be 750 divided by 900. Both the values are same. It will be 780 divided by 900. Now the third option will be 756 divided by 900. And the last fraction 43 divided by 45. So the changed value will be 43 multiplied by 2 means 86. So 860 divided by 900. And with respect to now 900 or same denominator, we can easily compare the numerator values. So 860 is the highest or greatest. So this is how we solve or simplify this type of problem sum. So I hope you have gained some knowledge in this class and my effort was worth. With that hope, I end today's class. Thank you.